Hello students, welcome to today's lesson where we are going to look at applications of heat transfer. We start with the first one. We have ventilation. So the purpose of ventilation is to supply fresh air in a room. So in our diagram here, we have the ventilators that are placed at the top. We have the position of the window and the position of the door. So inside the room, we have that the air is warm because it is being exhaled by the occupants in the room. And because it is warm, it has less density, therefore it rises up. As it rises up, it goes out through the ventilators. So the colder air, which is heavy from the outside, comes through the door and occupies the void that is created. That way we are able to supply this room with fresh air. Note that the ventilators are at the top because their purpose is to remove the hot air, which is always rising because of its less density. Then we move to the second application, that is engine cooling system. As shown in this diagram, this one is enhanced by both conduction and convection. So we move to the places that we have the metal surface. We find that the metal surface conducts away heat from the engine. As you can see the metallic body here. This is where we have the engine. So the metallic body conducts heat away from the engine. Remember, our purpose is to cool this engine. And then from there, we have the water that is passing through this. So that heat that is absorbed or that is conducted by heat surface heats up the water. When the water is heated here, it becomes less dense, and as shown by this arrow, it rises. As you can see the flow, it rises up. As it rises up, we have that it passes through where we have black copper fins. Remember, copper is a good conductor of heat. So as hot water passes through where we have the copper fins, those copper are able to get now heat from the water and they conduct that heat away, which implies that our water will lose some heat. We also need to note that these fins are made of copper because copper is a good conductor of heat. Then they are also painted black copper fins. Remember, black bodies are good absorbers of heat. So it will get a lot of heat from the water that is passing through those black copper fins. We also have the air. You can be able to see the air here. And the fan. So this will enhance cooling. We have the fast flowing air past the fins, speeds up the cooling process. So that way, we are able to cool the engine. Then we move to our third application where we have domestic hot water system. So as you can see in our diagram here we have a continuous flow of hot water, but the source of heat is just here. So what happens is that when you heat here at the bottom here, this water in this boiler becomes less dense and rises up through this. It rises up. Then the cold water that is heavy passes through these pipes and they come and occupy this piece. They in turn get heated, and as they get heated, they become less dense and rises up. As you can see in our expansion pipe, there is an outlet. And this one is just there to ensure that if there is overheating, you can be able to get the excess water from this pipe. Then we move to the material, the pipe that conveys the hot water and the cylinder. We say that they are lagged. Remember, this one we have said that it is covering with insulating or insulator. This will minimize heat losses from our water. Then we move to the fourth application. We have the solar heater. In our case here, we have two diagrams. So in this case, as you can be able to see here, remember a solar heater is used to heat water from the thermal radiations from the sun. So we have the pipe that is coiled where the water is passing, and then we have the storage tank here. So what we have is that the copper pipe is used because it is a good conductor of heat and will conduct heat into the water inside the pipe. So it is getting heat from the sun and then conducting that heat to the water. Then it is painted black because black bodies are good absorbers of heat, and therefore it will absorb a lot of heat from the sun. As you can see, it is covered, this part is covered with glass window, and this will allow the radiant heat to pass from the sun to pass through, and also it prevents the heat that is produced inside from being emitted. Therefore, there is a high temperature that is maintained inside. Then we have the black copper collector. Now this black copper collector, as you can be able to see, it is black because one, black is a good absorber of heat, and then it is made up of copper because copper is also a good conductor of heat, and therefore it's able to transmit that heat into water. Then we have insulating material. The insulating material prevents the heat loss or the heat loss from the pipe. That way we are able to maintain that heat is maintained in our pipe, so that heat hits the water. Then we have that the copper pipe is coiled several times. As you can be able to see here, it is coiled, and this one increases the surface area for heat absorption. Then we move to application number 5, which is the Amos Flask. As you can see, we have the types or the parts of the Amos Flask. We have the rubber band here, we have the cork or the stopper, we have the double walls, and these double walls are shiny. Then in between we have the vacuum, then we have the rubber ring pad, and then we have the shock absorbers. Then we need to know how each and every part prevents heat loss inside the Amos Flask. We start with the stopper. This prevents heat loss through conduction, because this one, the rubber, is a poor conductor of heat. Then we have the silvered walls. This one, the double walls, they prevent heat loss through radiation because they are shiny, and the shiny bodies are poor radiators of heat or poor emitters of heat. Then we have the vacuum. The vacuum is between the double walls. The vacuum will prevent heat loss through conduction and convection, since the two modes of heat transfer requires material media for transmission. And because there is no material, or it is a vacuum, then it means that heat is prevented through conduction and convection. Then we have the shock absorbers that are here. This one prevents the glass wall from breaking due to pressure from outside. Finally, we have the vacuum seal. It prevents air from reoccupying the vacuum, and therefore the vacuum remains a vacuum. That will ensure that our vacuum flask will ensure that the material that is hot inside will retain its heat. Then we have number 6, the greenhouse effect. So what is a greenhouse? Nowadays you can be able to see that greenhouses are made of plastics, but what happens is that the greenhouse is a phenomenon, or this effect is a phenomenon in which heat is allowed to pass through the transparent material but does not penetrate to the outside. So the radiant heat from the sun is able to penetrate, but the heat that is being produced by the plants cannot move out. So there is a high temperature, or there is accumulation of heat inside the house, and this one provides appropriate condition for the plants to grow, especially in cold regions or cold areas. Then number 7, we have solar concentrators. As you can be able to see, this one is where the rays of light or the radiant heat are reflected and they are brought to focus or to a single point. This is concave, the way it is curved, and it is shiny from this side. So as the radiant heat is coming from the sun, they meet the reflecting surface, they are reflected, and the reflection is bouncing back. They are reflected and they converge they come to a point, to a single point that we call focus. So if you put your water there at the focus, then you can be able to heat your water. So we have that the temperature at that point is very high. Therefore, the concentrated heat can be used to heat water, or you can even use it to cook. Then we move to another application. We say that houses in hot areas have their walls and roofs painted with bright colors from outside. Why? This is to ensure that they reflect away heat, so that inside the room you can have a conducive temperature. While in cold areas, their outer walls and roofs are painted dull. This is to ensure that they absorb as much heat as possible from outside. But when we come to hot areas, the walls and roofs are painted dull colors from inside. That is inside the house now. And this will ensure that they absorb a lot of heat. While in the cold regions or in the cold areas, the inside walls and roofs are painted with silvery or bright colors to reflect as much heat as possible back to the house, and therefore they are able to maintain a conducive environment. Then number 9, we have that kettle, cooking pans, iron boxes are polished. They are shiny, and this one will reduce the heat loss through thermal radiation. Then petrol tanks are painted bright or silvery bright to reflect away as much heat as possible. Then we have another application, that is land and sea breeze. During the day, we find that the land heats up much faster than sea. That is what we have in our diagram here. The air just above the rod gets heated up and rises up because it has reduced its density. So the air particles here are heated, they become less dense, and they rise up. The colder air on the surface of the sea will come to occupy the void that is created, and as they move, they form what we call the convection current, and that is what we are calling the sea breeze. Then in the evening, the temperature of the sea is higher. As you can see in this diagram, the temperature of the particles above the sea are higher, and therefore the particles rises up. Then the colder particles that are heavy from the land comes to occupy the void that is created. So at the end, you find that there is a convection current that is created. That gives us what we call the land breeze. So we move to the assignment. Again, these assignments are just testing what you have just covered. So take your time, do the assignment, and make sure that you get everything. So thank you, and prepare for the end of topic exam.